Hey students, welcome to video lesson 9.3. Today we're going to dive into the world of surface area again, but as it relates to cylinders. So let's go ahead and check out my screen and direct you to this. So the key idea in this case is going to actually be another formula. Previously, you were looking at pyramids, you were looking at prisms, and they had generalized formulas to go ahead and find the surface area, usually area of the base and then the lateral faces. Well, when it comes to a cylinder, okay, it's very similar to the prism. We are finding the area of the base, but the lateral face, interesting enough, or the lateral surface as they title it here, is a stretched out rectangle. So the net itself, you're going to notice the net when folded out creates two circular bases that are the same, equivalent, and then the lateral face is made up of the height along with the base being the actual circumference of the circle. So just imagine that you're taking the lateral face and unwrapping it, and the actual overall length is the circumference. So very nicely, whenever we are using using a cylinder and trying to find the surface area, it actually comes out to be a very organized formula. So it's another formula that you'll want to add to your notes and go ahead and memorize in this case. So it's S equals 2 pi r squared plus 2 pi r h. The 2 pi r squared comes from the fact that it's the area of the bases. It's the two circles. As we know, the area is pi r squared, and we double it. That's where that 2 comes from. And then the actual lateral surface, or that unwrapped blue surface, is 2 pi r in length. Okay, so 2 pi r is all the way across here. That's the circumference of the base circle, and then the height. So the area would be the circumference times the height. Add them together, we got the surface area of the entire unit. So let's go ahead and see if we can apply this. For the most part in this section, this is it. This is the formula, and that's all you really have to know. We're just going to go ahead and apply it. So let's roll down to example 1. And very standard, find the surface area of this cylinder, round your answer to the nearest tenth. So right now, first thing I would do is go ahead and put the formulas down. It's 2 pi r squared, that's the area of the bases, and 2 pi r h. Okay. At this point, take a moment to go ahead and substitute everything that you have in there and punch it out. I'll go ahead and do that and speed up the video just slightly to make sure that you see the end result and not the overall work. All right, on your screen, you should see the overall work pop up. Notice it does say round your answer to the nearest tenth, which I did. I did use the pi key on my calculator, so note that sometimes the book often uses 3.14, but if you use the pi key, the answer will be slightly off as it relates to the rounding. So don't stress about that. Just make sure you got the overall work and your answer is very close. It shouldn't be more than just a decimal point or two off. But overall, the key steps here, don't forget to put the proper radius in, and they gave us radius 4 millimeters, so that was nice. And then as I work my way down, I am going to point you to one key step that will help you simplify things just a little better. If you notice, once I got to this step, 56 pi, what I did was simplify the two parts of the cylinder formula to 32 pi plus 24 pi, and then I added 32 plus 24. I can do that because they both have pi there. If you get to this third step right here, 32 pi plus 24 pi, you can just use a calculator and punch that out. But I just did an extra simplification so you can see some more advanced algebra, things that you can carry forth. But overall, this is the main steps as it relates to just applying the formula. So take a moment to pause this video as needed, and we'll peek into example 2 here. All right. Let's go ahead and scroll. So example 2 is really no different from example 1, but it's just reading the question carefully to pick apart what you're actually solving for. So let's look at this. It says, how much paper is used for the label on the can of peas? And that's the key thing. We just want the label. So if you think about it, the label just goes ahead and covers the lateral surface or the lateral faces. So when I'm using that formula, I only want part of it. Okay. So in many of the problems that you're going to tackle in Big Ideas Math, they might ask you for just the basis or just the surface, or it's going to give you a word problem like this where you got to interpret which piece you actually need. So just be mindful of that. So what I'm going to do is just use part of it, 2 pi r h, and then substitute everything accordingly. So in this one, I really just need a couple pieces, and this one's a quick one. 4 pi would be the actual answer. Let's go ahead and punch that out on our calculator, round it to the nearest hundredths or tenths. I'm going to go hundredths this time. That's usually what I prefer. 12.57 inches squared. So the amount of paper is the surface area. For that label, it'd be 12.57. All right, at this point, that was a quick problem, but just interpreting what it's asking you. Take a moment to go ahead and pause this video as needed, and then we'll go into a heavy hitter, example number 3. All right, let's look at example 3. Example 3 uses a proportion setup, and I'm going to show you how this kind of works. It's something that we studied way back when. I believe it was like chapter 5, maybe chapter 4, right around there where we had to apply it. So let's read this. It says, you earn 1 penny for recycling the can in example 2. Oh, looks like I'm going to have to use some info from there. How much can you expect to earn for recycling this tomato can? Assume that the recycle value is proportional to the surface area. So anytime I see that magic word proportion and we're comparing two things, it's going to give us an opportunity to use a setup like this where we have something over something equaling something else over something, and we just got to be consistent what we put on top and what we put on the bottom. So let's apply this. First step is I probably should find the surface area of this shape. Okay, so but one thing you notice is that in example 2 I only found the label surface area. Okay, in this example, and I'm going to have to go ahead and further find the surface area of the entire shape, okay, to make sure that we have a proper conversion. So in example 3, it's almost like we got to redo example 2, but all it means is that we got to find the basis. So I'm going to go ahead and speed up this video in just a moment and show you the full work for the surface area of example 2 and the full surface area example 3. So take a moment to go ahead and do that yourself as you pause this video. All right, it should pop right back up here. Example 2 and example 3 surface area. It's the full surface area. Now, what we're going to use these for is to create the proportion to figure out what it would cost to recycle, assuming that they are proportional. So going back to this type of setup, what I'm going to do is put the surface area divided by the dollar amount equaling the surface area of the other can divided by the dollar amount. You can flip it. Remember how proportions work. As long as you're consistent what you put on top and the bottom, you can put the cost up top and the surface area at the bottom. So let's go ahead and do that. And it comes out to be 18.85 over x. That's what I'm trying to find from example 2. And oh, wait, nope. Let me go and double check that. It should be 0.01. Apologies for that, because you're already given that it's 1 penny for example 2. I'm trying to find example 3's surface area cost. So with that being said, let's go ahead and set it up and verify. This is what I'm looking at. It's for a surface area of 18.85. It is 1 penny. And then for a surface area of 94.25, that's what I'm looking for. So finish that. This is a classic cross multiplication problem. Okay, so once I do that, let's go ahead and punch out some of those numbers. Remember, cross multiplication just means you're gonna multiply the corner items here and these two corner items and set them equal to each other. So it's 0.9425 is approximately 18.85x. Solve for x in this case. So it should come out to be about 5 cents is approximately x. So answer statement, assume how much can you expect to earn? You can earn 5 cents. Now I'm going to show you something that will kind of give you a clue to how I could have figured this out without necessarily using a proportion. Let me zoom out so you can see the whole thing. But one of the things I've been continuously doing is showing you how you can use an exact answer with pi. Notice that the surface area of the can 2 is 6 pi, and the surface area of can 3 was 30 pi. 6 to 30 is 5 times the amount. So just thinking scale factors, it makes sense that if it is 5 times bigger, it's going to be 5 times the amount that you'll earn, and we actually got an answer that supports that. So I could have noticed that and just did 5 times 0.01, 5 times 1 penny, and it would have come out to be 5 cents. So the proportions work to prove that answer, but you'll start noticing that sometimes just doing a little bit of thinking of how proportions work can give you a little bit of insight into skipping a bunch of steps. Okay, so once again, 6 pi is and 30 pi is 5 times the amount of 6 pi, so we could have got the same answer. All right, so with that being said, pause this video as needed. I'm going to go ahead and scroll down to the OYO section and give you a couple problems to practice here. Okay? And there we go. So in front of you are 4 problems related to finding the surface area of a cylinder. I'm going to pause this video, let it run for about 5-10 seconds, and then all of the answers will pop up along with my explanation. So pause this video as needed. All right, students, so 1, 2, 3, 4 on the screen. So very straightforward, all of them. Just be mindful to double check if you're given the radius or the diameter. You should have noticed that question number 2 and 3, we were giving you the diameter, so you got to cut that diameter in half to use in the formula radius. And number 4 was one of those example problems again where you only had to find the lateral face, the label, so just be careful of interpreting that. So with that being said, at this point, okay, review the video as needed. You got work in Big Ideas Math Online and also the OYO for you to check. If you have any questions, feel free to reach out to me through email or whatever other resource that you have. All right, thanks for watching.